All right, partner. Keep on rolling, baby. You know what time it is.
Welcome to 4.5 ZPP, Zero Product Property. What we need to look at, methods to solving quadratic equations. So we learned about quadratic equations, now we need to solve them. 1, zero product property, that's what we're looking at today. We have the 2, the square root theorem. We're going to complete the square and quadratic formula. Meaning, this is what we're doing today, or right now. We'll look at square root theorem in 4.6. We'll look at completing the square in 4.6. And we'll do quadratic formula in 4.7. What we need to look at with steps. To solve by zero product property, the first thing we need to do is, if we look over here on the left, if A times B equals 0, then what do we know? You know that A has to be equal to 0, or B has to be equal to 0, or both. So in order to do this, what we want to do is we want to set, number 1 over here on the steps, we're going to set the equation equal to 0. By setting it equal to 0, we are now going to factor. So hopefully we can factor our quadratic. Then we have either a few terms, 2 binomials, they are equal to 0, so we set each factor equal to 0, and then we solve for that variable. Okay? And we should get the answer that relates to the zero product property. So number 1, if we try and factor this out, we notice a greatest common factor of x. X times x minus 16 should be equal to 0. We have 2 factors. We have the x and the x minus 16. We're going to set those both equal to 0. So x should equal 0, and x minus 16 should equal to 0. Well, we already have one answer. X equals 0, and then if we move the 16 over, we get x equals 16. There are 2 roots, 2 answers, that if we plug them in back into the original equation, here and here, we are going to get equal to 0. Okay, number 2, leading coefficient is a 1. So again, ask yourself, what times what equals 45? Adds to get negative 14. Ding, 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 ding. Hopefully you're thinking x minus sign in the middle. So we're going to go negative 9 times negative 5 should equal 45. Negative 9 plus negative 5 equals negative 14. So we just factored. Set them both equal to 0. So x minus 9 equals 0. X minus 5 equals 0. Solving, x equals 9. X equals 5. Hit pause. Try number 3. It's a doozy. Welcome back. If you notice, what I did for the first step is we need to set our equation equal to 0. So we had to add the opposite, or add 3 back to the left side. We get 3x squared plus 6x plus 3 equals 0. Now we go again, GCEF, greatest common factor, take out a 3. That gives us 3 times the quantity x squared plus 2x plus 1. Now we're looking at this trinomial. Can we factor that? What times what equals 1 adds to get 2. X plus 1, x plus 1. So now we have this third down here. So 1, 2, 3. We're looking at 3 times x plus 1 times x plus 1 equals 0. Now set each factor equal to 0. And ask yourself, does 3 ever equal 0? And the answer is no. So we're not going to worry about that factor. But what can we plug in for x? So we have x plus 1 equals 0 and x plus 1 equals 0. Both the same factors, so we really only have one answer, and the answer is x equals negative 1. Let's see if we can go backwards now. Let's see if we want to write the equations from the actual roots. So again, when we solve for x and we get an x equals, that's a root on a quadratic equation. So a root of an equation is the value that makes its equation true, or technically equal to 0. So now that we have the roots, 5 and 3, okay, can we use those to write the equation? Let's go backwards. So normally we have x equals 5 and x equals 3. Well, if you think back to the last problem, How did we get there? Well, we added or subtracted the number over when it was equal to 0. So let's move this 5 to the left by taking the opposite. So it now becomes x minus 5. Same thing with the 3. We're going to make x minus 3. So just moving it back, and now it's set equal to 0. Before we did that, if you remember, we had two factors. Well, those are our factors once they're set equal to 0. So we're going to take this x minus 5, and we're going to take this x minus 3, and we're going to multiply them both together on the left-hand side. So if we use our FOIL method, distribute, 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 you should get x squared minus 3x minus 5x plus 15 equals 0. So x squared minus 8x plus 15 equals 0. That is our quadratic equation. Box it. Go ahead and hit pause. Try number 2. Welcome back. If you notice, we have x squared minus 16 equals 0. So we set negative 4 and 4 equal to x. We moved both negative 4 to the left and 4 to the left, and you get x plus 4 equals 0, x minus 4 equals 0. Now we're going to take both of those binomials, we're going to multiply them together, set them equal to 0, and we get x squared. If you notice, a negative 4x and a positive 4x. So when we multiply this, there's a negative 4x, and this, there's a positive 4x, which gave us that 0x. So you may write it and keep it as 0x, or it's easier to just leave it out. So x squared minus 16 equals 0. Connection. What's this connection to the parabolas? In other words, what are these roots, if we forgot? Okay, we have graph. G of x equals x squared plus 2x minus 8. Well, again, you should look at that and see, I see standard formula. So if you have standard formula, we're going to use x equals negative b over 2a. In other words, we need to find the vertex. So negative b is going to give us negative 2 over 2 times 1, which gives us negative 1. So the x coordinate is negative 1. So I can bring that over here and put negative 1. In other words, our vertex is negative 1. Okay. What do we need to do? We're going to take that and we're going to input it into the g of x function. So we're going to get g of negative 1 equals negative 1 squared plus 2 times negative 1 minus 8 gives us 1 minus 2 minus 8. So when we plug that in, we get 1 minus 2, which is negative 1. Negative 1, negative 9 negative 8 make negative 9. So our vertex is negative 1, negative 9. Okay. To finish the graph, if you remember what we did, we're going to start with the x and we're going to go 2 numbers above. Hopefully you're choosing maybe 0 and 1. And then if we look 2 below, negative 2 and negative 3. By plugging in 1, you're going to get 1 squared plus 2 is 3. 3 minus 8 is negative 5. And if we plug in 0, you get negative 8. So if we plug in negative 2, negative 2 squared is 4. 4 minus 2 times negative 2 is 4 minus 4, which is 0. So 0 minus 8 is negative 8. So mirror image shows that we should get negative 5. So negative 3 squared is 9. 9 minus 6 is 3. 3 minus 8 is negative 5. So we have 5 points. So if I go over here and graph them, we get this picture. So far we get these dots. Now one thing we can do is if we take and set g of x equal to 0. So we put 0 equals x squared plus 2x minus 8. According to the zero product property, if we can factor that, we can get 2 more solutions. 0 equals, that would be 4 and negative 2. So x plus 4 times x minus 2. If we solve for that, you're going to get x equals negative 4 and x equals 2. What you've done is you've just found 2 more solutions or 2 more points. When x equals negative 4 and 2 equals x, okay, we get y equals 0. So I can put those points, and now you have negative 4, 0, and 2, 0. Go to the graph. Now you have these that pop up. So we see those 2 points that actually are the x-intercepts. So when we draw our line and comes up, we know that our parabola crosses at that point and that point. If you look above, what do these xi's correspond to on the graph? They are the x-intercepts. Conclusion again, the zeros of a quadratic function are the same as the x-intercepts. So if you need a couple more points, we can find the zeros or the roots or the x-intercepts, and they help us graph. Okay. Just recall, to find the y-intercept, which could be another point, you set x equal to 0, and to find the x-intercepts or zeros, set y equal to 0, and then use ZPP or zippy. Okay. So if we do this real quick, and we say let's find the y-intercept, meaning if we set x equal to 0, so f of 0 equals 0 squared plus 7 times 0 minus 60, which equals negative 60. So if I make a table over here, one of the points are 0, negative 60. Okay, so that usually gives us a point. Now if we go and we factor and try and solve, meaning set y equal to 0, so if the whole thing is equal to 0, and we get x squared plus 7x minus 60, we've got to think, what times what equals negative 60, but adds to get 7. Hopefully you're thinking, hey, 12 and 5. And we need a positive 7, so let's make it x plus 12 and x minus 5. If we solve, x plus 12 equals 0, x equals negative 12, x minus 5 equals 0, x equals 5. There's 2 other points we can get, 5 comma 0 and negative 12, 0. Congratulations. Don't forget to do your best. Forget the rest. Bye-bye for now. Look into my eyes. Congratulations. Catch you later.